can't.
Notes. We want to go through one problem today, and then we want to let you kind of.
Really?
Yeah.
Again?
Huh?
And we get to watch the Mayo commercial after.
Yeah, I'll try to find it.
And Jesus. It's really
Sure,
easy.
yep.
It's, you just type in Mayo cat commercial.
I'll do my best.
I found it during lunch. What are we making? Hey guys, should we make predictions on who's going to do the next halftime? I don't think so. I think it should be Taylor Swift next.
If it's Taylor Swift, I'm not watching the Super Bowl.
I hate Taylor Swift.
Okay, well y'all are just haters.
Yeah.
I agree.
Wow.
I am 1,000% a hater, and I own it.
All right.
It's
Thank
fine.
you. Thank you. Thank you for acknowledging your opinion.
I think Bruno Mars.
Bruno was great. Bruno was great when he did
Bring
it.
back Justin Timberlake.
Who doesn't like Bruno Mars?
Ooh, they might not let him.
Yeah, that kind of put a wrench into things for a while when he and Janet Jackson were on. So.
Well, I'm not saying they both have to do it together. I think that he can do it
Oh,
himself.
who knows what
Oh, I
happens?
remember
But then again, Bruno Mars was shirtless at the game, so I think
It was Usher.
equal.
Usher.
And
Usher
took his shirt off
too. Usher took his shirt off.
I don't know about Bruno. I
Yeah,
got
he's like 50.
And it was just like really awkward.
Yeah,
Like,
he's-
why did he have to take his shirt off?
Yeah.
And plus there was like that whole like microphone and tape that was coming off on his back. That was really an ick for me.
Yeah.
How old is Usher?
45.
I was
Dude.
like,
No.
oh,
Oh my
I
God.
I did not
definitely
need
looked
to
that up
see the
last night.
45-year-old man shirtless.
No, I.
He looked pretty good shirtless.
Yeah,
did.
You should try.
All right, let's focus. The net change theorem. The net change theorem. Net change theorem we did on Friday, and we saw that if you want to find the displacement of an object, you can simply take the integral of the velocity function. So notice it says f prime of t, namely that this is the whole idea is that this is a rate function. So if you take the antiderivative of a rate function, you come up with the position function. It tells you displacement. Do the absolute value, it tells you total distance traveled. The other thing we can determine is the average value of a function. So to try to help you understand what the heck this is talking about, you don't have to draw this, but I'm going to kind of help you out. So we're going to say that this is a value of 10 and 5, so on and so forth. And we're going to go from an interval of 1 to 6. I'm going to draw this function. There we go. Okay. So what I want you to do, what?
For that, the equation you just had us write, is it f prime of t
Yep.
is the rate or
Yep.
just the t?
F prime of t is the rate function. Yep. So I want you to have a conversation with the person next to you, okay? And I want you to decide between 0 and 6, what do you think is the average value of the function? So the function always stays between 0 and 10. What do you think is its overall average? Okay, it's a number somewhere between 0 and 10. Talk with your friend, decide what you think. Go ahead.
Oh my gosh.
9, 3, 4, 2. You're gonna stop.
Oh yeah.
like where it averagely is? Or what? I don't get it.
It's actually pretty complicated.
Where's that the most? I'm not sure. Like it is.
Okay, 5, 4, 3, 2, 1. Suppose that we sample the few spots. Suppose I sample the spot, say here and here and here and here. So that'll be 4, 5, 6, 7, 8, 9, 10. So if I added all of those up and divided by 10, about what are you saying I've come up with? Okay, about 7, 7.5, 6.5, 8, somewhere around there. The average value of a function, the way that we can actually compute that is by using this formula. It's very intuitive compared to what I kind of wrote down, and that is the integral of f of x dx from a to b. And what you do is, remember that the integral finds that total area, or rather the sum of all the heights. And what we do is we just divide it by the width. So 1 over b minus a is what we multiply by.
Can I put the multiplying on the other side since I didn't leave room?
Sure. So we're going to use those pieces to figure out these. Please make sure that your calculator is out, and we're going to start by typing in our velocity function. So I have 20 sine of pi x divided by 2 minus 1. My mode, I'm currently sitting in degrees. I need to be in radians. If you're borrowing your calculator, somebody that's in pre-calculus class, please make sure you check that. Go back to my y equals 20 sine of pi x over 2 minus 1. What's that?
Radians?
Yes. So everybody okay with what I have? So that's our velocity function. That is not the position function. But we're going to use this in order to answer the following questions. It is very important that you pay attention to what we're going to write down for our notation, because if you don't write down the right thing, there's a very good chance that I will take points off on the test for what you've communicated. I'll make that point clear here. It says, find the displacement of the car over the time interval. So notice, the velocity of a car is modeled by that, where t is measured in hours and v is measured in miles per hour. Consider over the interval of 0 to 4. First, let's make sense of this. What does the interval of 0 to 4 mean? In the first 4 hours, car is driving from time 0 to time 4 hours. Okay? It says S of 0 is equal to 10. Any idea what that means? Its original position is at the 10-mile mark. Okay? So for example, right now in Albert, we have to go out to Interstate 35. We would be at about the 13-mile mark. Whereas if you get up to Otani, you'd be at the 41-mile marker. Iowa would be right at 0. Okay? And then everything in Iowa is negative because it's Iowa. That's how it goes. But so I didn't get a single laugh out of that one. Wow.
I thought
Thank you. You didn't laugh. So I'll find the displacement of the car. Displacement, as soon as you see that, you simply think of this. Integral from 0 to 4 of v of t dt. On the AP exam and on my test, you do not need to rewrite 20 sine of pi t over 2 minus 1. You can simply just write that. But this is what we're going to calculate. So you've communicated to me that you know what displacement is. You simply do the integral of the rate function equals. And now you go to your calculator for the calculation. So on Friday, I showed you what to do without your calculator. Today, you get to use your calculator. Question?
How come it's v of t, not v prime of t?
So, good question. If you look up here, okay, notice how f prime of t, that's a rate function. We would say f of t is like s of t, the position function, whereas f prime of t is the derivative of the position function, which is v of t. So v of t is a derivative. It is a rate function. Velocity measures miles per hour, whereas s measures miles. This is a rate function. So when I say derivative, it is a rate function.
So when we're finding the displacement, we need the position function?
You need the rate function. You use the rate function when you're doing the displacement.
Oh,
Okay? What it will produce for us, instead of producing a rate, it will produce the antiderivative, which is miles. So let's produce that. I go back to my calculator and I second calculate. You can see the graph that it gives you. I'm going to calculate number 7, which is my second calculate, number 7. It's asking me for my lower limit, which is 0, enter, and my upper limit is 4. And that means its complete displacement, its total displacement over that time is negative 4 units. So does that mean it's traveled to the right or the left overall? It has traveled to the left. So I'm going to go back to this, and that gets negative 4 miles. find the average velocity. So notice the function that we're given. We are given the velocity function, are we not? And it's wondering the average value of that function. This is a new piece for you. The way we find the average or the mean value of a function is we simply do the integral, and we multiply it by 1 over b minus a. Okay? So over that given time interval, that time interval is from 0 to 4. So I'm going to go ahead and set up the integral from 0 to 4 of v of t dt. And what I put in front is 1 over b minus a. And what is 4 minus 0? 4. So I multiply by 1/4. Or in other words, you just divide it by the length of the interval. Okay? Do I already know what the integral from 0 to 4 is of v of t dt? Yeah, so we end up with 1 over 4 times negative 4, which is equal to negative 1. And my answer says that it's looking for what? Average velocity. So this is a measurement in velocity. So what label would we put to this? Miles per hour. So its average velocity is negative 1 miles per hour. So there are times where it's probably going fast to the right, sometimes it's going fast to the left, but those kind of balanced each other out. Overall, negative 1 miles per hour. Find the total distance traveled. How do we do total distance traveled? Absolute value. So we could find where it switches, or we could just plug in the absolute value. So what you want is the integral from 0 to 4 of the absolute value of v of t dt. So we did this by hand the other day. We looked, where is it that it changes direction? Try to find the negative area, try to find the positive area, add the two together. That's a lot of work, isn't it? Let's do the easier work. Let's just use our calculator to compute that. We go right up here, and I go into my y equals. And what I'm going to do is I'm going to take off the equal sign there. I'm going to go down to y sub 2. Anybody know what I'm going to press? Second, calculate. I'm going to grab the absolute value. Or second catalog, excuse me, yep. And anybody know what I press next? Yep, you need to grab y sub 1, which is in your variables. Go over to y variables. In your function, we grab y sub 1.
Say that again.
Press vars. Go over to y vars. Enter on function, and then enter on y sub 1. Okay. Make sure your first one isn't on, and only your second one is. We will second calculate, and we're going to calculate number 7. Number 7. We want to calculate from 0 to 4. So this, what do you want to call it? This car was traveling to the right. It was traveling to the left. Its total distance traveled over that time was 50.993 miles. On the AP exam, you could write 50.993 or 50.994. Sir?
How do you get from there again? So just that then.
Yep, but see how you have both of them, so you want to enter on that to take that off. So now you're using y sub 1. Now you second calculate. Number 7.
Oh, and then you can
Then go 0 to 4. Okay. Those 3 common questions are asked. Everybody okay on that? Okay, and on the tests I give you, I'll not necessarily ask them right in that order. So sometimes people try to memorize the order, like, oh, this is what I do for that and that and that. Try and mix them up so you understand what you're being asked in each situation. So just to review, if you're asked for the displacement, basic integral. If you're asked for the total distance, absolute value. Asked for the average value of the function, a 1/4 in front. Question?
We're gonna have to do it like the first way and this way?
No, just this way.
Oh,
By first way, you mean, are you going to have to do it by hand?
yeah.
No, I did that to help you conceptually understand what was going on. And you may come up with a problem like that on the ACT, or on the AP exam, but not here, okay? So now you need to understand the other questions. Find the position of the car at 2 hours and at 4 hours, okay? So let's just think about it right here. Where did the car start?
0.
At 10. It started at time 0. It was located at mile marker 10. What was its total displacement over 4 hours? -4. So if it was displaced -4 units, then where is its new position at 4 hours? It would be at 6, right? So this is the common sense piece that you want to think about. Position is equal to the start plus the displacement. Does that make sense? So I'm going to write out the expression for the 4 hours one because we've been able to think that through so far. So the position at 4 hours, I'll just write P of 4, position at 4 hours, is going to be equal to the start, which is 10, plus the displacement. I'm going to write it out so you can see we did displacement by going from 0 to 4 of V of t dt. Have we already evaluated what 0 to 4 V of t dt is? And what is that? -4. So we have 10 minus 4 is equal to 6 miles. That's its current location at 4 hours. If you look at 2 hours, its position at 2 hours is going to be equal to the start, which is 10, plus what? Integral from 0 to 2 of V of t dt. Do we know the integral of 0 to 2 of V of t dt yet? No. Can we figure it out? Yeah. I go back into my calculator and notice that this is the absolute value. We don't want that anymore, do we? So I'm going to go into y equals. I'm going to take the equal sign off of my y sub 2. I'll go back up to y sub 1 and press enter on that so I can make use of that. Now I will second calculate number 7. And I'm going to go from 0 to 2. And I get 23.464. $33.464 miles. That's its location at 2 hours. Any question?
Oh, it's 10 plus.
10
Sorry,
plus.
I missed that.
I think I had a time where I got out of the free response questions. So there's 6 of them, and each one's worth 9 points. I got 53 out of 54. I forgot to put a 10 on the front. Forgot to include the start. You know what I mean? So shoot. So I've never aced the free response section. I've come close, but I've never aced it. So now is the point where you really want to be able to see the difference between the types of questions. This one's easier to see. It says, find the acceleration of the car at 2 hours. How does acceleration compare to velocity? It is the derivative. So we have the derivative of velocity at time 2. Now, it is true that we can actually find the derivative of the function that's written down for us by hand, but in this situation, we're going to be asking that you use your calculator. And this will be what you'll be asked to do on your ACT exam, as well as this test as well. How do I find the derivative? Number 6, dy over dx is my derivative function, and I choose to do it at time, was it at time 2?
Yeah.
I type in 2, I press enter, and it says negative 31.415. That means it's traveling at negative 31.415 miles per hour.
So for like this one, you just have to identify that acceleration is the derivative. of
Yep.
velocity.
Is it per hour or hours squared? I thought it was so.
Oh yes, thank you, per hour squared. Velocity would be miles per hour, acceleration miles per hour squared. Now the last one, okay? What is the average acceleration over the time interval? Does everybody see how people can get question F, question E, and question B confused with each other? This says the word average. This says the word average. This says acceleration. This says acceleration, okay? So here's how you decipher, all right? First of all, average velocity. Are we given the acceleration function or are we given the velocity function? You're given the velocity function. So if it's asking the average value of the function you're given, then you use this formula that we have right there. Very clear? Okay, next one. As you look at this piece, it says find the acceleration. Is that asking for average? No, you're asking the instantaneous rate of change. The instantaneous rate of change is the derivative. Whereas the last one is also asking for a rate of change. Everybody agree acceleration is the rate of change from velocity? But it's asking for average rate of change. And the way we compute average rate of change is by using slope. So for this last question here, this is a fancy way of saying what is the slope between those values, okay? And that's what we're going to compute. So it says over the time interval, and the time interval is from 0 to 4. So we will find v of 4 minus v of 0 over 4 minus 0. That is average rate of change, okay? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to compute v of 4. How on my calculator could I compute v of 4? Yep, you got a couple options. You could go in your calculate option and grab value, or you could go to your table. That's my favorite place. And you press 4 and you press 0. Notice if you press 4, it said 5. Sorry about that. If you press 4, you get -1. If you press 0, you get -1. So as I type that in, I have -1 minus -1 over 4 minus 0. And what do you get? 0 over 4, or 0 meters per per hour squared. So understanding the difference between acceleration, average acceleration, and then average value of a function, those are very, very, very important pieces. Okay? So open up your assignment.
What is the average acceleration of 0? What does that mean?
The fact that it's 0 just means that the positive value and the negative value is kind of checked out over time, okay? Meaning that it's balanced out. It's had some that's positive, it's some that's negative, and it's evened out. But in terms of its average acceleration, just remember, my acceleration is, my acceleration is positive, okay, right?
Yeah.
Right now, is my acceleration positive or negative? It's negative. Acceleration has direction as well as velocity. So acceleration has direction both ways. So the fact that 0 doesn't mean it never sped up. It means it's sped up in the positive and it's sped up in the negative, and those cancel each other out. Okay. All right. So as you look at your assignment here, I want you to flip from this piece, and I want you to look at the one that it says use your calculator for the following problems. This is number 3. Number 3, 4, and 5 are basically set up just like we have. I have put some of the questions in a different order, and that's what you want to get used to writing. Please do not just give me a number on the test. Please also provide for me the integral telling me what you did. People make mistakes in their calculator. People don't always punch in the right numbers. So I'll be giving you a point for the right answer, but I'll also give you a point for this. In fact, on the AP exam, this part of the problem, a lot of times, is worth 3 points. They give you 1 point for the bounds, 1 point for the absolute value, and 1 point for the correct answer. That's 3 easy points out of 9. And yet, sometimes we still fail to get that. So please make sure that you're writing that down so I can see it. You have time to, I'm guessing most people will be able to knock one problem out at this time. Tomorrow, we will finish off this section by talking about looking at a table as well as looking at a graph.